Dear friends, now in today's session we are going to talk on the diesel cycle, which is the basis for all the diesel engine. In the last lecture we already discussed about a very important auto cycle, which is the basis of today's all petrol engine or SI engine, that is nothing but called as the auto cycle. We also learn how to derive the equation of mechanical efficiency for auto cycle and mean effective pressure for the auto cycle itself. Now in today's session, we are going to talk on the diesel cycle, which is the basis for all the diesel engine. With the help of this PV diagram, we are going to understand the diesel cycle. Again, we are moving towards the notes. With the help of the notes, we are going to understand the thorough knowledge of the diesel cycle. So, dear friend, this is the diesel cycle. It is also called as a constant pressure cycle. So, please don't get any kind of a confusion. Auto cycle is called as a constant volume cycle and diesel cycle is called as a constant pressure cycle. Okay, because in the case of petrol engine or that particular auto cycle, the heat addition takes place with constant volume. That's why it was called as a constant volume cycle. And here, the heat addition will take place, this QS, during constant pressure. Here, the pressure is remain constant. That's why this cycle is called as a constant pressure cycle. Okay, so in the year of 1897, Mr. R. Diesel invented this particular cycle, and on his name, this cycle was named as a diesel cycle itself. Now here we have pressure versus volume diagram and temperature versus enthalpy diagram. Again, similarly, this PV diagram shows the different pressures and volume during the process of diesel cycle and this temperature and enthalpy during the whole process of this particular diesel cycle itself. This is a theoretical cycle. Okay, again, in this case, as if you remember the auto cycle, the curves are different compared to the auto cycle. Auto cycle's curve are different and the diesel cycle curves are different one. So similarly, in the case of diesel engine, we are using diesel as the fuel instead of petrol. In the case of auto cycle, we have to use petrol as a fuel and air fuel mixture will come inside the engine cylinder. So in the case of a diesel engine, the process 0 to 1 is again suction, 1 to 2 is a compression, 2 to 3 is heat addition process, 3 to 4 is isentropic expansion, 4 to 1 is heat rejection and 1 to 0 is the exhaust process. And these are the different pressure and volume during the whole cycle. Again 1 to 2, 2 to 3, 3 to 4, 4 to 1. These are the different processes which explained with the help of this particular TS diagram, and this 2 to 3 is constant pressure cycle or constant pressure one, and this 1 to 4 or 4 to 1 is called as a constant volume cycle. So here we will understand all these things in thoroughly. So initially, in the case of diesel engine or diesel cycle, only amount of air will get come inside the engine cylinder. This is called a suction process. And during suction, the volume is going to increases and the pressure of air remain constant. During the compression process, whatever amount of air is present inside the engine cylinder, it will get compresses and this will come under process 1 to 2. This is called isentropic compression process. During this process, pressure of air will going to increases and its volume is going to decreases. Okay. Similarly, in the case of diesel engine, here during process 2 to 3, here we are not using any kind of a spark plug, but here we are using injector. Always, my dear friends, in the case of diesel engine, we have to use injector. So, as process 1 to 2 indicates the compression process, the temperature as well as pressure of air will going to increases, and with this increase the pressurized and temperaturized air, we are going to provide the diesel spray with the help of injector, and that is called heat supplied. Okay, and this process 2 to 3 is called the heat supplied process, where the injectors inject the amount of diesel inside the engine cylinder. Okay, so this process 2 to 3 is a heat supplied process where the injector injects the diesel inside the engine cylinder, and this process represents P2 is equal to P3. Pressure remain constant but volume is going to increases from V2 to V3. Means as diesel will come inside the engine cylinder along with the air, its pressure remain constant but its volume is going to increases. So this is called constant pressure cycle, constant pressure heat addition. And similarly, next again 3 to 4 is expansion, as the diesel and air will start to burn and that burning takes place, and again expansion will proceed, and it will explain with the help of process this 3 to 4. During this process, pressure is going down from P3 to P4, its volume is again going to increases. Again 4 to 1 is a heat rejection, but this heat rejection is a constant volume. That's why this is called constant volume heat rejection. Pressure drops down again, P4 to P1, and volume remain constant, and finally the exhaust process 1 to 0. So this is again the PV diagram for the diesel engine. If you observe, the heat addition takes place at constant pressure and heat rejection takes place at constant volume, whereas in the case of Otto cycle, both the process heat addition and heat rejection at constant volume. That's why it was called as a constant volume process, and this diesel cycle is called as a constant pressure cycle. Always remember, dear friends. Okay. Similarly, during this particular processes, suction, compression, heat addition, expansion, heat rejection, and exhaust. These are the different points of temperature as well as the entropy. Okay. Now, similarly, we are moving towards to see this particular derivation part of the diesel cycle. This is again very important. So, to analyze the diesel cycle, we have to use the volume ratio. Let us consider V1 by V2 is equal to R. This is the volume ratio, and cutoff ratio is R suffix C. This is V3 by V2. Okay, so V1 by V2 is present over here. V1 by V2 is this particular volume ratio, or let us consider, or we can say compression ratio, and this V3 by V2 is nothing but called as a cutoff ratio. Let us consider, and here we have considered that things over here. Okay, so similarly, if we want to write the equation for heat supplied and heat rejected, as we already discussed about the Otto cycle, we can write mass of fuel into specific heat at constant pressure, because heat supplied process is at constant pressure and heat rejected process is at constant volume. So that you can write this MCP into T3 minus T2, this T3 minus T2, and here MCV T4 minus T1. We can write like this. Give equation number 1 and equation number 2. So similarly, we can write efficiency equation for diesel cycle is equal to work done divided by heat supplied or input. So output by input is nothing but work done by heat supplied. Okay, so in this case, what is the work done? This QS minus QR is the work done and heat supplied is the input. So again, simplify the equation, we will get 1 minus QR by QS. So put the values of QR and QS in this equation, we will get the next equation like this. Okay, so the same term will get cancelled, and finally what is remaining, this mass and mass will get cancelled. The term will remain 1 minus CV by CP into T4 minus T1 divided by T3 minus T2. So again, further simplification, we can write the equation like this. Okay, so now again further simplification of this particular diesel cycle efficiency, we have to write the adiabatic index. We know the adiabatic index is a gamma and its standard value. So here again you require the basic knowledge of thermodynamics. The gamma is nothing but Cp by Cv. Always the adiabatic index is the ratio of specific heat at constant pressure, Cp represents, and specific heat at constant volume, Cv represents. Okay, so let us consider gamma is equal to Cp by Cv. So again put that equation over here. Cv by Cp is again present over here. So you can convert that denominator to numerator. So we can write instead of gamma, so we can write Cv by Cp replaced by gamma. So we can write 1 by gamma, and again the equation becomes 1 by gamma into T4 minus T1 divided by T3 minus T2. Give equation number 1. Okay, clear I think up to this point. So again, concentrate on the next statement or next step. So now we consider with the first process, that is 1 to 2 process, that is isentropic compression. So again, going to see the diagram, 1 to 2 is isentropic compression process, and now we are going to write the equation for this particular first process 1 to 2. Dear friends, we have to write the equation for all the process 1 to 2, 2 to 3, 3 to 4. Okay, like that. So we start with the first process. Somewhat lengthy derivation is there as compared with the auto cycle. So again, after getting equation number 1, now we are moving towards the process 1 to 2, and this process is isentropic compression process. So for this process, again we have ideal gas constant equation, P1 V1 by T1 is equal to P2 V2 by T2, as we already discussed in the auto cycle itself. And similarly, for this adiabatic isothermal cycles, we can write P1 V1 raised to gamma is equal to P2 V2 raised to gamma, and we can write the simplified equations by closing the terms of volume with each other, V1 by V2, where the gamma is a common term, so we can write V1 by V2 raised to gamma is equal to P2 by P1. Okay, just rearrange the terms. Similarly, as we just discussed, V1 by V2 is nothing but called as this compression ratio. We can write, we already written over here, V1 by V2 is equal to R. So put that value over here, V1 by V2 replaced by R. So we can write R raised to gamma is equal to this P2 by P1. Okay. So similarly, the next one, P2 by T1 is equal to P2 by P1 into V2 by V1. Okay, so again rewrite the equation. P1 V1 divided by T1 is equal to P2 V2 divided by T2. Okay, and here we simplified about this equation. P1 V1 raised to gamma is equal to P2 V2 raised to gamma. Please concentrate on my statements. Okay, this is again very easy. Only need to understand this thoroughly. Okay, so in this case, again, this T2 by T1 is equal to P2 V2 by P1 V1. So write that equation over here and simplify the equation. P2 is equal to, take down this T1 over here. Instead of P2 by P1, we already calculated the value of P2 by P1 is equal to this R raised to gamma. Put this R raised to gamma over here instead of P2 by P1 into this V2 by V1 is nothing but called as, we already discussed, 1 divided by this particular R. Okay, again if you see over here, this V1 by V2 is equal to R itself. Okay, so put that values and write down the next equation. We have this V1 by V2 is equal to R raised to gamma is equal to P2 by P1, and in this equation here P2 by P1 is nothing but R, and so that we can write the equation, get that T1 over here. So T1 into this R raised to gamma into V1 by V2 is nothing but R, so we can replace like this 1 by this particular R. Okay, so similarly finally we can write T2 is equal to T1 into this R raised to gamma minus 1, because here we have 1 by R. So once that denominator will come to the numerator, so here you have to write minus 1, so the term become R raised to gamma minus 1, and this is equation number 8. From process this 1 to 2, that is a compression one. So similarly, process 2 to 3, this is the constant pressure heat addition. Second process. Okay, again moving to the diagram, we just had 1 to 2. Now 2 to 3 is a heat addition process. Now again write down the equation for that one also. So we can write again, here we already considered R suffix C is equal to V3 by V2. R suffix C is equal to V3 by V2, that is the cutoff ratio. And again for ideal gas we have, for the next process P2 V2 by T2. Now this is process 2 to 3, that's why here we have to consider third process also, P3 V3 divided by T3. Again simplified this equation, get the temperature term closer to each other. So T3 by T2 is equal to, take down this P2 over here, P3 by P2 into V3 by V2. Again simplify the equation, V3 by V2 is nothing but R suffix C, we already considered. Concentrate on this mouse indicator, so put this value over here. So just note down that R suffix C is nothing but V3 by V2. So the further simplification, but P2 is equal to P3. Yes, correct. So again move to see the diagram. This P2 is equal to P3. So both the values are same. So there is no need to again write the separate values of it, so that we can write P2 is equal to P3. So this will cancel to each other. Now what is remaining? This T3 is equal to T2 into R suffix C. This is equation number B. Okay, so similarly from equation number A and B, what we can write? Here is equation number A and here is equation number B. So what we can write? Equation number A, and from equation number B, we can put the value of T2 over here because we already calculated the value of T2 in equation number A. So put this value in this equation and we can write the next equation. T3 is equal to T1 into R raised to gamma minus 1 into R suffix C. This is equation number C. Okay. So, dear friends, in this case, the next process, that is considering process 3 to 4. Okay. Now we are moving to see the process 3 to 4 and finally 4 to 1. So 3 to 4 is isentropic expansion process. So we have to write the equation for this. So similarly, as we already written for compression process, we can write for process 3 to 4. So this process is nothing but T3 by T4 is equal to V4 by V3 raised to gamma minus 1. As we already discussed for the process of compression. Similarly, we can write this equation. Okay, so T3 by T4 is equal to V4 by V3 raised to gamma minus 1. But in this case, V4 by V3 is nothing but V1 by V3. Okay, so this V4 by V3 is a combination of this V1 by V3. Okay, so 0 to 1 is suction, 1 to 2 is a compression, 2 to 3 is a heat addition. Okay, and finally expansion will start. So how expansion will start? After completion of all these processes. So we have to write V1 by V2 and then this V3 by V2. That is a complete process of V4 by V3. So that we can write over here the distribution of that particular process. V4 by V3 is nothing but V1 by V3 and that is nothing but V1 by V2 into V2 by V3. Further simplification is possible. So again V1 by V2 is nothing but R and V2 by V3 is nothing but 1 by RC. So rewrite the equations and we can write the equation for this one. V4 by V3 is nothing but R divided by RC. Put this equation in this above equation. T3 by T4 is equal to R by RC raised to gamma minus 1 as it is. We have written this equation. Okay. So finally again further simplification, take down this T4 over here and this R divided by RC raised to gamma minus 1 at this side, left side. So finally we can write this equation in simplified manner and we can get T4 is equal to T3 into RC divided by R raised to gamma minus 1, give equation number D. Okay, so similarly from the above equation again we can put the value of T3 over here because we already calculated the T3. Okay, we already calculated T3 in equation number C. So we can put the value of T3 in this equation of T3. Okay, and rewrite the equation for T4, put all the values and this becomes, after simplification, this becomes equation number E. Okay, so this T4 is equal to T1 into R raised to gamma minus 1 into RC divided by R raised to gamma minus 1 itself. And finally, we have written over here this T1 into whatever terms are there, it will be get cancelled. This R raised to gamma minus 1, here also this 1 divided by R raised to gamma minus 1, both will be get cancelled. So finally put all the values over here and we can conclude this final equation of the mechanical efficiency of diesel cycle like this after putting all the values in equation number 1, and this is the final equation of mechanical efficiency of diesel cycle. Please concentrate. And similarly this is the mean effective pressure equation of diesel cycle like this one. So dear friends, hope you understood this one. So this is all about for the diesel cycle. So thank you so much.